Welcome back, everyone. So in the last video, we talked about TCP/IP. And you remember when I showed you that example with the mail where we broke it up into kind of like puzzle pieces, and then I explained what TCP does and what IP does? So TCP/IP you can see as TCP. UDP is a different protocol. UDP/IP, you can pretty much see it like that. But the whole idea between these two is the way that we get data from one computer to another over the internet. And these two protocols are often used, most times even in conjunction in systems, but they're both used to get data from one source to another. And for us, because we talked about TCP a little bit more, where it's connection-oriented, meaning that we need to establish that connection between device A and device B, and also we need to transmit data in two directions. A can transmit data to B, B can transmit data to A. So let's go a little deeper into that so we understand how that works. So let's say we have our client and we have our server. Again, we're talking about two computers, right? And I mentioned that clients, which is the actual user's computer, and servers, which is where we are probably hosting all of our web applications, both of these are computers. So here, when we want to communicate from one to the other, what needs to happen is that the client most likely is going to try and establish a connection to the server. And the server, once the connection is established, understands, and now data can get sent both ways. Client sends requests, server sends responses. This data flows in two directions. Both are able to receive and send data to each other. So remember, the key thing about TCP, it's a two-way connection. Data can go both ways. Now here, in order for this to happen, we need to make sure that we're actually on the same page. And remember, the main thing here is that we need to ensure that we are getting the correct order of data. We need to ensure that the data is all received. So this happens through the establishment of something called an ISN, which is an initial sequence number. Both the clients and the server both have their own ISN, and it's a randomly generated number. It's just a way for us to track on the server and the client whether or not we have received the correct ISN from the opposing system. So if the client wants to send data to the server, it's going to send its ISN. So the server is then going to respond to me like, hey, I did get your number. I'm ready for whatever data is associated with this number. Because as the numbers change, it knows what the corresponding data for that number will be. So remember, we're just using the number, the ISN, to track what the data is going to be. And because both sides are trying to send data to each other, they both need to keep track of each other's ISN for that connection. The ISN represents the data being sent over for that current session connection that is established. A different connection is different data altogether. So that's why the ISN is also randomly generated, because they don't really correlate to each other. As far as sessions go, like the connections between each other, we don't really care. Once one session is done and the next one starts, there's no correlation between those two sessions anymore. The actual TCP just governs essentially what's important within one connection session. The client wants to establish the connection to the server. So it will randomly generate an ISN. Let's say it's some number X. Could be 1, 2, 3, doesn't really matter. It's just some value variable X. It will then send a synchronization request to the server with that ISN as part of the package. So part of the data that's being sent is the ISN itself, the number of X. It'll be like, hey, my ISN number is X. I want to synchronize with you, SYN. I want to synchronize with you on the server. The server is then going to receive that value, see the ISN. It's going to say, oh, I got X. I'm going to acknowledge that I got X. Now, the way that I acknowledge that I've received this synchronization request with this number is I'm going to add 1 to this number. That's just how the protocol works. You don't want to think too deeply about why these things are specifically done this way. Again, they're rules. So the way that this rule set dictates that this happens is that once you increment this number by 1 and you acknowledge back to the client that this is what happened, then the client's like, okay, I've properly synchronized with the server. But now remember, this server also wants to send data back to the client, meaning that it itself also needs to synchronize back with the client with its own ISN number. So the server will generate its own ISN number as well. Y, for example, let's say it's 999. And then it will also send as part of that acknowledgement back to the client also a synchronized message as well saying, hey, my ISN number is Y. The client has now done two things. It's recognized that it's been acknowledged of this value x plus 1, but also it's going to acknowledge that the server has sent it some ISN of y. So it's also going to now send back an acknowledgement for y plus 1. Now realize in this acknowledgement message says, hey, I acknowledge that I'm ready for x plus 1. And our client is saying, hey, I acknowledge that I'm ready for y plus 1. The reason for this is because now when we send data between the two servers, we're going to send it with data including the ISN of x plus 1. And similarly, the server is going to send data to the client with ISN of y plus 1. The moment that we receive data and we see inside that this ISN has the actual acknowledged ISN numbers incremented, we know what session, what data is correlated to in our communication. So this protocol gets established this way. This really sounds a lot more confusing than it is, but it's really quite simple. Our client is saying, hey, for this current session that I'm sending you data, I want you to know that the data is associated to 1, 2, 3. So the server is going to be like, oh, 1, 2, 3. Okay, I'm going to accept that. I acknowledge that. And for the session, I'm just going to say, when you send me the data, send it to me with the message 1, 2, 4, so that I know to correlate that to 1, 2, 3, what you sent me. So within this range of some ISN number plus 1, our respective systems know what the correlated data when sent is associated to. The reason for this is because data gets sent in chunks. It doesn't always get sent in one giant message. Remember, this TCP is a connection. That means there's an open and a close. That's why I keep saying session, because the data keeps transferring between the two sides. It only closes when we recognize that it's done. So if we're sending numerous packets of data once this connection is established, that data, as we saw before, can get pieced back together. It might get sent in 4 different pieces. But again, some data might get lost along the way. So we don't close that connection until we have all of it. And as I mentioned, TCP is waiting. It's doing polling, essentially. It's saying, hey, I'm supposed to receive 4 pieces. I only got 3, and I'm missing the 4th one. Can you send it again? But because we're receiving numerous data, potentially, maybe over multiple connections, how do we ensure that we know that the data we're receiving, which one to associate it to? We associate it by this ISN number, and the connection, the session that is established has some associated ISN number. And we use that plus 1 as part of the data so we know what to correlate to what session for. Now, I'm really just showing you this because I think it's important for you to know the mechanics of why this guarantee of data delivery is happening. And the majority of web applications are really going to use TCP. Examples of TCP, this protocol, is HTTPS and HTTP, which we're all very familiar with as being what sends much of the website data between the server and a client. The reason why this is the case is because when you think about the user experience, you need to guarantee for the user that all of the data they need in order to enjoy your application is actually being sent over. If you think about sending a React website, for example, what if we break up the packets? As we know, we chunk data all the time, and we send it over the network. It doesn't even matter if we chunk it. Most likely, it's going to get chunked in some way. Let's say some of those chunks don't make it, and they contain the core functionality of the React package. The entire website is just not going to function without that complete amount of data being sent. So that's why TCP, with its guaranteed delivery of data, is so critical and pretty much what drives the majority of the web. Now, you might be wondering, well, if it's not TCP, what's that UDP one you mentioned, Yihua? So that's what we're going to talk about in the next video. There's limited use cases of when you use UDP, but it is important and it is used, especially in the future. And we're going to talk about why, because it is faster than TCP. And we're going to talk about all that in the next video. But for now, I just want you to understand with TCP what's happening here and just really focus on the fact of guaranteed delivery of data. One other thing about TCP as well, as with anything in networking, I've given you an overview, but this topic is incredibly, incredibly dense and deep. Do you need to go this deep yourself for system design? Most likely not, but it's still something that if you're interested in and need to, it is something that is a very deep topic. But for our needs, this is enough for us. So let's move on now to UDP.